In the second part of 1.7, we'll be combining function notation and piecewise functions. Let's say we're given the following piecewise function and we're asked to evaluate f of 6. Well, you have to realize that 6 is an x value and 6 falls in this portion of the domain. So therefore, I am going to use the equation x squared plus 7 to evaluate f of 6. So I'm going to replace 6 in place of x. So it's going to be 6 squared plus 7. So 36 plus 7, so that's going to equal 42. All right, in part B, I'm looking for f of negative 4. Again, negative 4 falls in this portion of the domain. So therefore, I have to use the top equation. So it's going to be negative 4 minus 3, which is going to be negative 7. For f of 11, f of 11 now falls in the part of 8 to infinity. So therefore, I'm going to use the function root x. So this is just simply going to equal root 11. And f of 2 just falls in the interval again here. So I'm going to use x squared plus 7. So this is going to be equal to 2 squared plus 7, 4 plus 7, which is going to be equal to 11. So that's how you evaluate piecewise functions if you're given the x value. Now, you have to be able to distinguish between that first example and the second example. In the second example, we're given a piecewise function and we're asked for values of x that make the function equal 26. So now we have to deal with all three parts. So let's take the first function, x squared plus 1. Let's make that equal 26. I'm going to solve for x by subtracting 1 from both sides. And when I evaluate, I get plus or minus 5. Now, you have to check, do plus or minus 5 fall in this interval? Well, the only one that falls in that interval is, sorry, not positive 5, but negative 5. So there is your first solution. Then I have to take 2x minus 3, which is my middle function, and make that equal 26. Again, solving for x, I would add 3 to each side, divide by 2, and 29 over 2 is my solution for x, but that does not fit between 0 and 8, so this is not a valid solution. In the last case, we're going to let 3x plus 2 equal 26. Again, solving for x, I get 3x is 24, and x is equal to 8, and 8 is part of that domain, so this is an acceptable answer. So those would be my two solutions for this question. Okay, I want you to pause the video and give this next one a try. Okay, well, I'm hoping you've had a chance to try this example. So let's go through the three cases again. So x squared plus 1 has to equal 0. I take the 1 over to the other side, and you can't solve this, so there's no solutions for the first part of that. For the second one, 2x minus 3 equals 0. Again, solving for x, I get x is 3 over 2, and 3 over 2 does fall in there, so this is a valid solution. And then the last one, it is 3x plus 2 equaling 0. Solving for x, that's going to be negative 2, and x is going to be negative 2/3. And negative 2/3 does not fall in the interval 8 to infinity, so that just doesn't work either. So this is the only valid solution I have for this question. So it's very important that you distinguish between the two different types of questions. One, when they're giving you an x value and you're asked to evaluate, and two, when they give you a value of the function and you're trying to find x values that will equal that value of the function. All right, so there's your assignment for the second part of piecewise functions. So give those a try, and again, you can check your answers on the website.